In 1942, Lieutenant Commander Sam Porter climbed into the cockpit of a brand new F4U Corsair aboard the USS Sangamon in Chesapeake Bay. His mission was simple: test whether this revolutionary fighter could land on an aircraft carrier. 4 attempts later, Porter refused to continue. Not because he lacked courage, he was convinced the aircraft was actively trying to kill him. This wasn't an isolated incident. At Marine Corps Air Station, Mojave, 144 training accidents occurred with this single aircraft type. Young pilots nicknamed it the Ensign Eliminator, a darkly ironic title for a machine designed to protect them. By the end of World War II, 1,435 Corsairs were destroyed in non-combat accidents. That's more than 7 times the number lost to enemy fire. Yet this same aircraft achieved an 11-to-1 kill ratio against Japanese forces, claiming 2,140 enemy aircraft whilst losing only 189 Corsairs in actual combat. Japanese pilots called it whistling death. Marine pilots who mastered it considered it the finest fighter of the war. How does an aircraft become both the most feared weapon in the Pacific and the deadliest threat to its own pilots? The engineering decisions made in 1938 would create a paradox that challenged every assumption about fighter design, and the solutions to that paradox would influence naval aviation for decades to come. This is the complete story of the F4U Corsair, the fighter that terrorized everyone who encountered it, including the men who flew it. In February 1938, the United States Navy Bureau of Aeronautics issued a request for proposals that seemed almost impossible. They wanted a single-engine carrier-based fighter capable of exceeding 400 miles per hour, a speed no American single-engine fighter had ever achieved. The aircraft also needed a minimum stalling speed below 70 miles per hour, a range of 1,000 miles, and the ability to operate from aircraft carriers. To understand how audacious this request was, consider that in early 1938, the Navy's frontline fighter was the Grumman F4F Wildcat with a top speed of 318 miles per hour. The Navy was effectively demanding an aircraft 30% faster whilst maintaining carrier compatibility, 2 requirements that seemed fundamentally opposed. Rex Beisel, chief engineer at Chance Vought Aircraft, believed he could meet this challenge. His solution centered on the most powerful engine available, the Pratt & Whitney R2800 Double Wasp. This was an 18-cylinder, 2-row radial engine, producing an extraordinary 2,000 horsepower, nearly double the power of contemporary fighters. But this enormous power created an immediate problem. To harness 2,000 horsepower, the Corsair needed a massive 13-foot diameter Hamilton Standard Hydromatic 3-blade propeller. For perspective, that's nearly 4 meters of spinning metal, the largest propeller ever fitted to a single-engine fighter up to that point. Here's where the engineering compromises began to cascade. To prevent that colossal propeller from striking the carrier deck during takeoff and landing, Beisel needed extraordinarily tall landing gear. But tall landing gear meant increased weight, drag, and structural weakness. The solution he devised would define the Corsair's appearance and create its deadliest flaw. Beisel designed an inverted gull wing, a wing that angled sharply downward from the fuselage before leveling out. This ingenious configuration allowed shorter, stronger landing gear whilst providing the necessary propeller clearance. The design looked distinctive, even revolutionary. It also earned nicknames like the bent-wing bird, and would become one of aviation history's most recognizable silhouettes. On the 29th of May 1940, test pilot Lyman A. Bullard Jr. took the XF4U-1 prototype on its maiden flight from Stratford, Connecticut. The results exceeded all expectations. During testing, the prototype achieved 405 miles per hour in level flight, making it the first American single-engine fighter to break the 400-mile-per-hour barrier. The Navy was ecstatic. On the 30th of June, 1941, 6 months before Pearl Harbor, they ordered 584 production aircraft. This was one of the largest single orders for a fighter aircraft in American history up to that point. But as the prototype underwent further testing, disturbing problems began to emerge, problems that would claim the lives of dozens of pilots before solutions were found. As production F4U Corsairs began rolling off the assembly line in June 1942, Navy test pilots discovered that the aircraft's revolutionary design came with catastrophic handling characteristics. The first major problem involved the fuel system. The original design placed fuel tanks in the wings, similar to most fighters of the era. However, when engineers increased the armament from 4 to 6 Browning 50 caliber machine guns, 3 in each wing, those wing fuel tanks had to be removed to make space for ammunition. The solution was to install a single large fuel tank with a capacity of 897 litres directly behind the engine, in the forward fuselage. This required extending the aircraft's nose by an additional 12 feet forward of the cockpit. To maintain the aircraft's center of gravity, the cockpit itself was moved nearly 3 feet aft, positioning it behind the wing's trailing edge. This seemingly minor adjustment created the Corsair's deadliest characteristic. The pilot could not see forward or downward during critical phases of flight. When configured for landing nose angled upward, airspeed reduced the massive engine cowling, and long nose completely obscured the pilot's view. Landing signal officers, carrier decks, even the horizon itself disappeared behind nearly 4 meters of aircraft, structure directly in front of the pilot's face. But the visibility problem was only the beginning. When the Corsair slowed to landing speed, something far more sinister occurred. The massive propeller, spinning at high RPM, created a powerful spiral of disturbed air, what engineers call propeller wash. This spiraling airflow didn't affect both wings equally. The left wing experienced a loss of lift before the right wing, creating an asymmetric stall. At low altitude, during the final approach to a carrier deck, one wing would suddenly drop without warning. Pilots had perhaps 2 seconds to react before the aircraft rolled inverted and struck the deck. The third critical flaw involved the landing gear's oleo struts, the shock-absorbing hydraulic cylinders that cushioned touchdown impact. The Corsair's oleos were calibrated too stiffly. When the aircraft touched down, instead of absorbing the impact, the struts compressed fully and then rebounded violently. The Corsair would bounce sometimes as high as 10 to 15 feet, frequently vaulting completely over the arresting wires designed to stop it. If the aircraft bounced at an angle, or if one wheel touched before the other, the result was often catastrophic. Pilots described the experience as attempting to land a bucking bronco on a postage stamp whilst blindfolded. Adding to these difficulties, the cowl flap actuators, mechanical systems that adjusted engine cooling, had a tendency to leak hydraulic fluid directly onto the windscreen during approach. Pilots attempting carrier landings through an oil-smeared windscreen, unable to see forward, wrestling with unpredictable stalls and violent bouncing, faced an almost impossible task. The statistics tell the story. During initial carrier qualification tests in September 1942 aboard USS Wolverine, USS Core, and USS Charger, the accident rate was catastrophic. At Marine Corps Air Station, Mojave, just one training facility, 144 Corsair accidents were documented. Pilots created gallows humor to cope with the danger. They called the F4U the Hog due to its difficult handling. Others used the nickname Ensign Eliminator, a reference to the rank typically held by newly qualified pilots. The implication was chilling. Inexperienced aviators didn't survive their first encounters with the Corsair. By late 1942, the U.S. Navy made an unprecedented decision. Despite having ordered nearly 600 of these fighters, they declared the Corsair unsuitable for carrier operations. The aircraft, that was explicitly designed as a carrier-based fighter, was banned from carriers. Instead, all production Corsairs were diverted to the United States Marine Corps, which operated primarily from land bases in the Pacific Theater. The Navy chose to standardize on the Grumman F-6F Hellcat, a newer design that was considerably easier to land on carriers, despite being somewhat slower than the Corsair. This decision should have ended the Corsair's story. Instead, it marked the beginning of its transformation from a feared killer into a legendary weapon. Marine Fighter Squadron VMF-124 became the first operational Corsair unit, receiving their aircraft in late 1942. On the night of the 11th to 12th of February 1943, they arrived at Henderson Field on Guadalcanal, one of the most contested airfields in the Pacific. The next morning, their first missions began. The Corsairs immediately demonstrated their extraordinary performance. In level flight, they could exceed 420 miles per hour, more than 80 miles per hour faster than the Japanese Mitsubishi, a 6M0. In a dive, Corsairs reached 550 miles per hour. Nothing in the Japanese inventory could match this speed. But on the 14th of February, 1943, Valentine's Day, the Corsair faced its first major air combat test. A mixed force of 12 Corsairs from VMF 1, 2, 4, along with Army P-38 Lightnings and P-40 Warhawks, escorted B-24 Liberator bombers to Bougainville. Approximately 50 Japanese fighters intercepted the formation. The engagement was a disaster for the Americans. 8 fighters and 2 bombers were lost, including 2 Corsairs. 1 Corsair collided with a Zero, killing both pilots. The Marines quickly dubbed this action the St. Valentine's Day Massacre. The problem wasn't the aircraft's performance, it was pilot inexperience with the Corsair's capabilities. The Marines had been flying the comparatively docile F4F Wildcat, which emphasized maneuverability over speed. The Corsair demanded entirely different tactics. Experienced pilots quickly learned the Corsair's strengths. Unlike the Zero, which excelled in slow-speed turning fights, the Corsair dominated through speed and energy retention. A Corsair pilot who maintained high speed and used diving attacks could repeatedly strike and escape before Japanese fighters could respond. The 650 caliber machine guns, firing nearly 5,000 rounds per minute combined, could destroy an unarmored Zero in seconds. Within months, as Marine pilots adapted their tactics, the kill ratio began to shift dramatically. But there was still one critical problem. The aircraft's reputation for killing its own pilots remained justified. Marine pilot First Lieutenant Kenneth Walsh exemplified the Corsair's potential. On the 15th of August 1943, whilst escorting bombers to Vila Airfield, Walsh's formation was attacked by approximately 50 Japanese fighters. Walsh shot down 4 Zeros in a single engagement. 2 weeks later, on the 30th of August, he downed 4 more enemy aircraft before his Corsair was hit and he was forced to ditch in the ocean. He was rescued and subsequently awarded the Medal of Honor. Another pilot, First Lieutenant Robert M. Hansen, accumulated 25 confirmed kills in just 6 months of combat. Gregory Pappy Boyington, commanding Marine Fighter Squadron VMF 214, the famous Black Sheep Squadron, was credited with 28 aerial victories before being shot down and captured on the 3rd of January 1944. He survived Japanese captivity and received the Medal of Honor. But for every Pappy Boyington or Kenneth Walsh, there were pilots who never mastered the Corsair's unforgiving characteristics. The accident rate remained appalling. Of the total 2,020 Corsairs lost during World War II, 1,435 were destroyed in non-combat accidents. That's nearly 70% of all losses. The Marines needed their fastest fighter operational on carriers. The question was, could anyone solve the Corsair's fundamental design flaws? In November 1943, 95 F4U Corsairs arrived in Britain under the Lend-Lease program, designated Corsair Mark I by the Fleet Air Arm. British pilots, already experienced with difficult carrier aircraft like the Supermarine Seafire, approached the Corsair's problems methodically. The first modification addressed the wingspan. British carriers had lower hangar deck clearances than American carriers. Fleet Air Arm engineers simply cut 8 inches from each wingtip, reducing the overall span by 16 inches. Remarkably, this modification had minimal impact on performance, whilst significantly easing hangar stowage. The second modification was more significant. British engineers identified that the stiff landing gear oleo struts were causing the catastrophic bouncing. They replaced a single valve in each strut assembly with a softer responding component. This simple change dramatically reduced the bounce on touchdown, making landings more predictable. But the breakthrough came from British carrier doctrine rather than engineering. Royal Navy pilots developed a curved approach pattern that kept the carrier deck in sight throughout the final approach. Instead of approaching straight in with the carrier directly ahead, forcing pilots to look past the long nose, British pilots flew a continuous left-hand turn, only straightening to align with the deck in the final seconds before touchdown. This kept the landing signal officer visible through the port side of the canopy throughout the approach. American pilots had been trying to see through an obstacle. British pilots simply looked around it. The U.S. Navy and Marine Corps quickly adopted this curved approach technique, but there remained one more critical safety modification to implement. Engineers at Vought, working with field reports from both American and British pilots, developed the stall strip, a small metal wedge, only about 8 inches long, riveted to the leading edge of the right wing, outboard of the gun ports. This deliberately disrupted airflow over the right wing, causing it to stall simultaneously with the left wing. The asymmetric stall, the killer that had claimed dozens of pilots, was eliminated by intentionally creating slightly worse aerodynamics on one wing. The solution was counterintuitive but effective. By early 1944, these modifications had been incorporated into new production aircraft and retrofit kits for existing Corsairs. The F4U 1A variant featured an improved canopy design that replaced the original birdcage canopy with a single-piece bubble canopy, raising the pilot's seated position by 8 inches and significantly improving visibility. In April 1944, the U.S. Navy finally cleared the Corsair for carrier operations. The fighter that had been banned from carriers 20 months earlier returned to its originally intended role. The Ensign Eliminator had been tamed, though it would never be considered an easy aircraft to fly. Once the handling problems were resolved, the F4U Corsair's combat record became extraordinary. By VJ Day on the 2nd of September 1945, Corsair pilots had destroyed 2,140 Japanese aircraft in aerial combat. Only 189 Corsairs were lost to enemy fighters, an 11-to-1 kill ratio that represented one of the highest combat effectiveness ratings of any fighter in World War II. The Corsair's versatility extended beyond air superiority. Marine units discovered the aircraft excelled as a fighter-bomber. The strong airframe could carry substantial ordnance, 2 1,000-pound bombs, or up to 8 5-inch high-velocity aircraft rockets, in addition to the standard 6 machine guns. Charles Lindbergh, yes, that Charles Lindbergh served as a civilian technical advisor with Marine Air Group 31 inches 1944. On the 3rd of September, Lindbergh flew a Corsair carrying 3 1,000-pound bombs, dropping this 3,000-pound load on enemy positions at Wotje Atoll. 5 days later, he dropped a single 2,000-pound bomb plus 2 1,000-pound bombs, a 4,000-pound payload that pushed the aircraft to its structural limits. By the Battle of Okinawa in 1945, Corsairs were delivering 70% of all bombs dropped by U.S. fighter aircraft in the Pacific Theater. Marines on the ground, watching Corsairs provide close air support, nicknamed them the Angels of Okinawa. The Japanese had their own name, Whistling Death. The sound came from the air rushing through the oil cooler intakes and other openings at high speed, creating a distinctive, terrifying whistle that announced a Corsair's diving attack seconds before rockets and bullets arrived. Production numbers tell the story of the Corsair's success. Demand exceeded Vaught's manufacturing capacity, requiring Goodyear Aircraft and Brewster Aeronautical to produce additional units. Goodyear's aircraft were designated FG-1, whilst Brewster's were designated F3A1. By the war's end, more than 12,580 Corsairs had been manufactured. The F4U became the longest produced piston-engine fighter in American history, with production continuing from 1942 to January 1953, more than 11 years. No other World War II fighter remained in production for even half that duration. But the Corsair's story didn't end with World War II. When the Korean War began in June 1950, the F4U returned to combat. By this time, jet aircraft dominated air-to-air combat, but the Corsair proved invaluable for close air support and ground attack missions. The robust airframe and powerful engine made it ideal for carrying heavy bomb loads and sustaining battle damage. On the 10th of September 1952, Captain Jesse Folmar of Marine Fighter Squadron VMF 312, flying an F4U 4B Corsair, engaged a Soviet-built MiG-15 jet fighter over the west coast of Korea. In an extraordinary dogfight, Folmar, flying a piston-engine fighter designed in 1938, shot down the jet. He became the first and only pilot to destroy a jet fighter whilst flying a propeller-driven aircraft in the Korean War. Minutes later, additional MiGs attacked Folmar's damaged Corsair, forcing him to eject. He was rescued almost immediately by helicopter, surviving to tell the story of perhaps the most unlikely aerial victory of the jet age. Navy Lieutenant Guy Bordelon Jr., flying a radar-equipped F4U 5 Newton's night fighter variant, achieved ace status in Korea by shooting down 5 enemy aircraft during night interception missions. He became the only U.S. Navy ace of the Korean War, and likely the last pilot in history to achieve ace status flying a piston-engine fighter. The last combat use of the Corsair came from an unexpected source. In 1953, the United States authorized the sale of 94 brand-new F4U 7 variants to the French Navy. These specialized ground attack versions fought in French Indochina, later Vietnam, then in Algeria, and finally during the Suez Crisis of 1956. The final F4U 7 rolled off Vaught's production line on the 31st of January 1953. It marked the end of the longest production run of any American fighter from the World War II era. When the last Corsairs were finally retired from military service in the late 1960s, the type had served for more than 25 years, an extraordinary longevity for any combat aircraft. The F4U Corsair began as a death trap, an aircraft that killed more than 1,400 American and British pilots in training and operational accidents. Its revolutionary design, built around the most powerful engine and largest propeller available, created handling characteristics so dangerous that even experienced test pilots refused to fly it. Yet through systematic engineering improvements, innovative operational procedures, and the determination of pilots who refused to give up on its potential, the Corsair transformed into one of history's most effective combat aircraft. Its 11-to-1 kill ratio, achieved against determined and experienced opponents, stands as testimony to what the Corsair became once its demons were tamed. The lessons learned from the Corsair's development influenced naval aviation design for decades. The importance of pilot visibility, the dangers of asymmetric stalls, the need for progressive test programs, these insights, purchased with the lives of young pilots at places like Mojave, helped create safer aircraft for subsequent generations. Today, approximately 35 F4U Corsairs remain airworthy worldwide. When they appear at air shows, that distinctive inverted gull wing and the deep roar of the Pratt & Whitney R2800 engine evoke an era when fighter design pushed beyond the limits of what pilots could safely manage, and when those pilots found ways to exceed even their own limits. The Corsair killed its own pilots. It also saved countless lives by achieving air superiority in the Pacific, protecting Marines on the ground, and demonstrating that even the most flawed design can become legendary when human ingenuity and courage intervene. That is the complete story of the F4U Corsair, the fighter that became an icon by conquering the terror it initially inspired.